All right, the second part of the video is talking about infinite geometric series. Okay, so if we look at these two different infinite geometric series, you can see that this one has an R value of 1/2 because 1/4 divided by 2. And then this one has an R value of 2. So as you compute the partial sums here, you can see they're getting bigger slightly, but they're never going to get to 1. So this series is going to converge to 1, where this series, because the R is 2, is going to get bigger and bigger, and this is going to go off actually to positive infinity. So for infinite geometric series, if the R is less than 1, it converges and we can find a sum. But if the R is greater than 1, then we find and we say no sum because it diverges. There's no bounding on it. So what you're going to need to check when we do these next few problems is the value of R. So if your R is less than 1, so if your R value is less than 1, then we're going to say the series is convergent. If your absolute value of R is greater than 1, then it's divergent, which means no sum. Your infinite geometric sum is small too, so it's going to be S equals A1 over 1 minus R. And you notice there's no N. There's no N because we don't have to sum a certain number. It's going to converge to a value, and that's all we need to do. So the beginning of these, you just want to check, is it a convergent or a divergent? And again, that's your R value. So we'll compute the R first. If it converges, we're going to find the sum. So it means we're going to use this formula. This is only for infinite. So how you're going to know infinite is these dot, dot, dots here. Those tell you infinite. We have some summations down here. You've got infinity on top. So just have to pay attention because these will definitely be mixed in with some of the other ones we've already done. So if we look at this first one here, we have that the R, so R is negative 12 divided by 2, which is negative 6, which is definitely greater, and you're looking at the absolute value, is greater than 1, so this is going to diverge. So if we were trying to find a sum, we would basically say that there's no sum. Try the next one. You're going to get R equals 24 over 72, which is 0.3. So this one is going to converge, so we will find the sum on this one. So we'll say first it converges. And then to find your sum, that's your first term, A1, and then R is your ratio. So you're going to do S equals A1 is 72 over 1 minus 0.3. Again, just put all that in your calculator. For the 0.3 though, make sure you put the repeating and all the decimals, otherwise it will not work out. So sometimes it's better to change it to 72 over 1 minus a third. And then from there, 1 minus a third is just 2/3. So now you have 72 over 2/3. If you flip and multiply, and then you can cross some stuff off. So this will be a 1, and this will be 36. And then 36 times 3 will give me 108. So just be careful on 14. If you kept it 0.3 and you did this in a calculator and you did not use the repeating, you're not getting 108. Your answer would be wrong. So just watch out for repeating decimals. Either use the entire decimal or, do something different. All right, I'm going to skip those next two. I'll come back and put those in. You can check them in the answer. So do these two on your own to see if you get it. And then let's look at 17. So 17 again, we know that it's geometric because we can compare the geometric formula. So again, just go back to the answer key and do these on your own so you get practice. Okay, and the answer key is on Canvas. For these ones, we can tell that it's definitely infinite. So this is your A1, this is your R. So we can see that our R is 3/4, which is less than 1. So then we can go ahead and do the formula. So the formula again is S equals A1 on top over 1 minus R, which is 3/4. Now this one, if you do in the calculator, it's going to be fine because it's not a repeating decimal, so both ways should work. So this one does converge. Got to write the first answer. So converges, and your sum should equal 896. So that means this series here, that when you do it to infinity, will get really close to 896, but it will never cross 896, and it's similar to the one we did before. And then if we go ahead and look at 18, okay, infinity, okay, check your A1 and your R. So here's our A1, here's our R. Again, look at the absolute value. So it definitely converges because R is 0.2. It's negative technically, which is less than 1. So it converges. So if we do our formula for this one, so your S is equal to 45 over 1 minus a negative 0.2. So just be careful with that math. You want to chop, chop, make it plus. So you're going to get 37.5. Okay, and then 19 and 20. 19, there's your R value. 7 over 6 is definitely greater than 1, so it diverges. So we don't have to solve it. It will have no sum. That's usually how we write the answer, is we write that there is no sum because the R value is too big. Here we can see that the R value is 1/2, so it converges. And then plugging in, and just again, be careful with anytime you have negative. So S is equal to negative 8 over 5 over 1 minus 1/2. This one, again, should be fine on the calculator because of the fact that they're not repeating decimals. So you should get negative 3.2. If you have any questions at all on anything, send me a Canvas message. I'll be answering them throughout the day. And then hope to see you guys on Tuesday. Have a great day.